Okay, so good afternoon, everyone. Welcome to APNIC eLearning web class. Today is the 25th of January in 2017. It's 1 o'clock in the afternoon from Brisbane in Australia, where I'm conducting this class. The topic that we are going to cover is about DNSSEC. Now, a lot of people find this topic pretty hard because of some of the complexities and new concepts that are introduced in this topic. So we will try in this session to explain to you, okay, in as much basic details as I can, how this works, what this is all about, and what problem we are trying to solve. Before going through the rest of the session, I would like to quickly just introduce myself and what this platform is about. My name is Sheryl Hermoso. I work as a training officer for APNIC, the Asia Pacific Network Information Center, which is the internet registry for the Asia Pacific region, for our region. Now, we are part of the training team that conducts face-to-face workshops to members of the internet community. And we do topics that are related to the internet, of course, things like IPv6. We do routing related topics, routing, BGP, MPLS. We have security topics such as network security, okay, DNS and DNSSEC as well as those that are related to the core function of APNIC, which is internet resources. So we have internet resource management. Did I say IPv6? IPv6 is, of course, a very important topic as well. Now, we do conduct this e-learning sessions for those of you who cannot attend the face-to-face workshop. This runs for 1 hour, and I do tend to encourage people to join and participate by writing their questions or comments in the chat panel. You can see where the chat is. If you have anything to say, please feel free to write them down. At the end, I will be asking you to fill in a quick survey, which helps us improve our e-learning program. Okay, so what are we going to try to cover here? Now, in the previous session, which most of you have attended, don't worry if you haven't attended that, because we will explain this as much as we can. Doesn't have to rely on that, but it's just a good introduction of what are the issues with DNS when it comes to security, and what are the different ways to secure the system. One of that is, of course, by using security solutions that answers issues on transactions. Now, that is beyond the scope of this session. Our focus is protecting the actual data itself. What do we mean by data? When you do a typical DNS query, you ask for particular information, particular mapping. Say, for example, you have a domain name and you want to find the IP address corresponding to that domain name. Obviously, that query goes into the DNS server. It can be the other way around. You have the IP address, you're querying for the domain name. It can be other information as well, such as CNAME, NS records, SOA records, MX records, and things like that. Those are what we call generally as DNS data, the actual information, the actual mapping that you will get from a server, which is authoritative to give you that answer. Okay, so I hope that's clear, because that's what we're trying to protect here. Why? Why do you want to protect DNS data? First of all, when you receive a query, if you're a server, when you receive a query, you give an answer. If you are the recursive server, when you do a query, you receive an answer. Now, by trusting the DNS hierarchy, you know, or you kind of like trust that this is coming from the right source. In this case, the authoritative server. But as a resolver itself, your machine, do you do any checking? Do you do any verification? Actually, no, you don't do that sort of verification. So how can we now implement that? What are the ways to do those types of verification? First, why do you need to verify? Well, you want to make sure that, one, this data came from the right source, which is your authoritative server, And next, this data is correct. Say, for example, it really came from the authoritative server, but maybe somewhere along the line, someone was able to do a man-in-the-middle attack and then inserted wrong information in there, and the information that you have now, instead of pointing to 192.168.1.1, it points to another IP address. So that is still wrong information. The data has been manipulated in transit, but there is no way for you to verify that it actually has been changed. Right? So what you want to do here, basically, okay, if you look at this holistically, you want to verify that the data that you receive is correct and coming from the right source. This is what we call as integrity check, which is part of the CIA goals, right? Your goal for security. And as I've previously mentioned, and I always say this, with DNS, data is public. You don't generally just send all of this information out. You still need to query, but information can be queried by anyone generally on the internet, right? Particularly if you are an authoritative server. You can query about your domain and things like that. Okay, so it is public data. So what you want is not to encrypt this data, because it's not just going to specific people, it's going to mostly everyone who wants to query for that domain. But you want to provide integrity check. Alright, so that's what we're doing here. If you see this, okay, this shows us the different possible issues and vulnerabilities in the DNS system. Okay, I have actually a slide, and it's not here, that shows you, okay, where to point to find those vulnerabilities. Actually, it's everywhere. So when it comes to DNSSEC, what are we trying to protect? We want to avoid things like cache impersonation. We want to avoid cache pollution. What is that? With cache impersonation, this is my machine. This might be your laptop or your mobile phone that does this resolution. This is your DNS server. Someone can pretend to be this DNS server, and you want to avoid that. You want that to be coming from your DNS server that you have configured. Another one is for this resolver or recursive server, you want to get that from the correct authoritative server, from the correct master and slave servers. You want to avoid cache pollution or data spoofing. Okay, with cache pollution, you have a malicious person or a malicious machine somewhere outside, maybe sitting somewhere here. And then when you do your query, it responds to that query. So if the answer arrives first to your recursive server, it will be accepted. Why? Because I did this query, the answer came to me, so I can assume that this is correct. Yes? But again, there's no verification there. Okay? Actually, with that example, it came from the wrong source, not the actual authoritative server. So you see the problem there? Okay? There is no way of verifying that this actually came from the right source. So someone can just pretend to be that authoritative server, spoof the data, give you wrong information. And we want to avoid that. Okay? So with DNSSEC, that's what we are trying to do. So if the concept of the problem and the solution to the problem is clear, we can continue with discussing this particular solution. Okay, so the problem is, okay, you have received DNS data and you want to verify it. Okay, solution is verifying them using this new protocol, which is DNSSEC. Well, technically, if you look at it, this is a set of standards, RFC 4033, 4034, and 4035, that collectively comprises DNS security extensions. Why are we doing this? Okay, and how is this going to work? This security extensions is going to be part, kind of like you say, it's an update or an additional set of protocols that can be implemented on top of your DNS protocol. Why? Again, same problem, right? And you want to protect the integrity of your data by doing a few things. One is here, you want to protect this data by digitally signing the data itself. Think about asymmetric key cryptography. If you want to send an email to someone and you want to verify that it's coming from you, you can digitally sign that document. The document can still be read by anyone, but now there is an attached signature. So you send out the email, you send out the signature. Once it is received by that person, he can verify that this email is correct by using the digital signature, and then also finding the actual signature based on the public key of the email itself, and then do a comparison. That is digitally signing. Okay, if that concept is clear, okay, you can now just map that same concept in DNSSEC. Same thing. You are doing query for a particular data, resource record. Resource record arrives and you want to verify it. How? This resource record that you receives has a corresponding digital signature, and you're now going to validate that this is correct by looking at that digital signature. Okay, so we are implementing DNSSEC by using what we call as public key cryptography, asymmetric key cryptography. What is that? It's basically it's a type of cryptography that uses two sets of keys, a public key and a private key. So you generate this key, they're generated at the same time, but one key is to remain public. Okay, it can be shared by anyone, it can be posted anywhere, and the other one should be private at all times. Okay, so you have a private key and a public key. You use one key to sign, use the other key to verify. You can also use one key to encrypt, use the other key to decrypt. Okay, so essentially one key for one purpose, and it will be decrypted or verified using the other key. Okay, again, what we want here is data validity. So you check for authentication and integrity. So you're going to now sign using the private key, and then the public key will be used to verify. Okay, so I hope that concept is clear with everyone. So that's a form of digitally signing the data. And at the same time, we're also going to do this, establishing a chain of trust. Okay, so that is the concept of DNSSEC. So when that is clear, now I guess the next question will be, okay, but how? How are you going to implement that? Okay, so this is how it's done. First, I think some of you have heard this in the previous session. So first, you have records, resource records. This is your DNS data. Your DNS data will be signed. What are you going to use to sign? Your private key. Okay, and then with that, the signature itself, the output of that signing. Okay, so you have a record, you sign that, the output is your signature. Your original record will be published, the signature will also be published. At the same time, the public key that's used for that signing will also be published. So you have the original resource record, you have the public key, and you have the output signature, all of which should be published. Okay, next one, you also have child zone. So what is a child zone? So in DNS, it's hierarchical, right? So you have the concept of delegation. Someone is managing .com, and then they can delegate, say, Sheryl.com, maybe to me. So I now manage that. That is a child zone of .com, the top level domain. Okay, same thing, say APNIC.net. And then we have training.apnic.net. Training.apnic.net is a child zone of APNIC.net. So since there is now a separation of responsibilities, training.apnic.net administrators are different from apnic.net. So we will do the signing, we will do the administration of this child zone separate from the parent. Okay, so you have your .net, It's signed by the administration. APNIC.net, which is delegated to another set of admins, signed by those admins. Training.apnic.net, again, being someone else is in charge, so they will sign it separately. That's what we mean here. Child zones will sign their records separately using their own set of generated public and private key pair. Okay? And then, how do you now, link the parent to the child zones? Originally, in DNS, we have glue records. So when you cannot answer the question or the query because this subdomain has been delegated, I have this glue record that points to that child zone. Now, how do we cryptographically verify that linkage? We use, again, the public key. In this case, we will have a hash value of that public key. It will be added to the parent. Okay, but I wouldn't worry about that as for now. Okay, we will look more into that last part, particularly this last two later on. But I guess if you're gonna get something out of this slide, make sure that you understand the first three. Okay, how do we verify? It's by first, if you are the administrator of a particular zone, you have to do the signing of the records in that zone. And then make the signature public, make the public key public, and of course the record again, because that's the same DNS data, it will still be public. Next, how DNSSEC works is it's either one of two things, okay? Depending on where you are. Actually, it can also be both. Say, for example, you are maintaining training.apnic.net zone. You are authoritative for the zone. You're maintaining the servers for the zone. In your case, you will have to do the signing. You have to sign your zones. Okay? You configure your server so that people can query your authoritative server and you can respond with the data, the resource record, and the signature. Okay, so that's what you do if you're an authoritative server. However, another instance of deploying DNS is by only having like a validating resolver. Okay, you're not managing or you're not in charge of any authoritative zones, but you are the DNS server for, say, a company or an enterprise network. All those machines, okay, are using your DNS server as a recursive server, and it does the query going to the authoritative server. So the most of the conversation, the chunk of the conversation will be between the resolver, recursive server, and the authoritative server, right? So if you are managing this validating resolver, what do you have to do? You still have to configure your DNS servers so that when it queries the authoritative server, it will also look for DNSSEC signed zones, DNSSEC signed data. Okay, so those two, you need both of them. All right. Now, to implement this, we will introduce a few changes, additions to the DNS protocol. One of that is the introduction of new resource records. What are the resource records that we're familiar with right now? A record, quad A record, so that's v4 and v6 addresses. We have pointer, CNAME, okay, NS records. Those are all resource record types. Now, aside from those are the most common ones, right? Aside from those, now we are going to introduce a few more. Okay, particularly we have 4 more resource records. Okay, the first is your RRsig, also called the resource record signature. Another one is the DNS key. Okay, and then you have the DS or delegation signer. And then the last one is NSEC, next secure, or NSEC 3. NSEC 3 is the newer, better version of NSEC. So it's one of two. Like you either use the NSEC or the NSEC 3. So these are the 4 new resource records. Please try to remember them. Again, it's RRSIG, DNS key, DS record, and NSEC or NSEC 3 records. Now, once you remember that, let's try to understand what their functions are. Okay, so RRSIG is said to be a signature over the RR set. DNS key is your public key. DS record is your pointer for the chain of trust. NSEC is an indicator of missing or unavailable records in a zone. Now, that might not be clear yet. So the best way is for us to go back into the, like say, where is that? Like how DNSSEC works. This one, right? This defines the basic functions of DNSSEC. You have records, you sign these records using the public key, and then you publish the signature, the output signature. So which resource record comprises for this one? When we say records here that are signed, this is your resource record. But actually, you don't sign one record at a time. You sign a set of records. So we call it the RR set. For example, in your zone file, you have 3 A records next to each other, followed by, say, 3 NS records, followed by 3 CNAME records. So you don't sign each A record by itself. You group together all the A records. This is an RR set. You sign the RR set. Okay? So which record will be the output of that signature? That will be your RR sig. So you have an RR set, which is a group of resource records with the same resource record type. You sign this using the private key, and the output is your signature, the RR sig. Okay, so the signature is published actually also using the DNS system. Okay, it is going to be published as a type of resource record, which is your RR sig. Okay, now how can the user verify this? You now have your record, you have your signature. Of course, you need the public key to also be published. How do you propagate the public key? Typically, generally in a public key, right? It can be something that you put up on a key server. Maybe it's something that is attached on your mail or posted on your website. But in DNS, the easiest way is, of course, add it as a resource record again in DNS. So we have this new resource record, DNS key, that contains the value of the public key. Clear enough? Okay, so that's already 2 or 3 records. So you have your RR set, which is essentially just your typical resource records. You have your RR sig, which is the signature, output signature of the RR set. And you have your DNS key, which is your public key. Next, child zones are signing their own set of records with their private key. So it's the same thing. That's also going to have like your RR sig and RR set and DNS key. However, we need to link, okay, the parent to the child zones. Okay, as I've said before, you have these glue records, but how do we cryptographically link parents to child? We are going to use the DS record. What's a DS record again? Going back here, it's a delegation signer. It's a pointer for building the chain of trust, the chain of authentication. So what we're doing here is you have your public key, right? Public key tends to be long, depending on the key size that you use to generate. It can be 128 bits, 256 bits, 512, it can be even longer, 1024 or 2048 bits. So it can be very long. So it's not a good idea to just give this whole public key to your upstream or to your parent zone. So the easier way is to create hash of that public key. When you say hashing, you're using an algorithm to generate a fingerprint of that public key. So it's a smaller size, usually a fixed size representation of the original data, in this case, your public key. So that's what we have there. The hash value, okay, will be added into the parent zone as a DS record. Okay, so far, out of these resource records, we have already discussed 3: RRSIG, DNS key, and DS record. So I hope these 3 are clear to everyone. Now, what is the use of NSEC or NSEC3 record? It says next secure. What does that exactly mean? Think, for example, a zone file. A zone file contains many records, right? All of your mappings are in your zone file. It can be a text file or it can be in a database. Think of it as a text file for now, so that it's easier. You will have many records there. So maybe all of your machines will have a corresponding domain name and IP address. Now, what if I query for, say, I looked for a machine or a server called, I don't know, Sheryl.example.com. Your domain is example.com. So you have a.example.com, b.example.com, c.example.com, etc. But you don't have Sheryl.example.com. What is a possible issue here? Maybe if someone requests for this domain, okay, someone can respond that, hey, this is the answer. This is the mapping that you're looking for. But actually, I don't have that in my records. Which means there's no way for them to verify because I don't have it. I can't give them a public key. I can't give them a signature for that record. So with NSEC, okay, this is a way of saying that this record does not exist. How? We do that by pointing everything that exists in my zone file. So when you see next secure there, it's kind of like listing down all of the resource record types that are existing in your zone file. Okay, so I have this A record. What follows after this A record? Oh, I have the CNAME. After that, I have an NS record. After that, another A record. So your NSEC record will have information about that list. A record followed by CNAME, followed by NS, etc. Clear enough? So those are the 4 resource record types. Okay, so I hope that's clear. Now, let's look at examples, all right? So it's easier for us to see this. You already know what's a resource record, right? This is an example of a resource record, mapping from a domain to IP address. I have example.net, and it maps to IP address 192.168.1.1. Now, what is an RR set? A set of records with the same name, class, and type. So these are all A records. So I can say that yes, this can be an RR set. I have 3 records in this RR set. So as I've said earlier, DNSSEC signs the RR set as one, not individual records. Okay? Next, DNS key. This is an example. What is the content of the DNS key? Your public key. You are making that public by adding it as a DNS key record in DNS. So if you notice, this is my domain, irashai.net. Resource record type is DNS key. And somewhere here, okay, you can see this like weird set of data there is your key. Okay, what other things can you find there? Now this is not clear. This is not properly set up. But this red one points to 256. It's a 16-bit flag that tells you whether it's a ZSK or a KSK. Now don't worry if you don't understand what they are for now. Essentially, okay, you will have 2 sets of keys. You will generate 2 sets of keys, KSK and the ZSK. This one shows you whether this is a ZSK if it's 256, it's KSK if it's 257. Okay? The next one, this 3 value here is your protocol octet. 5 here is the algorithm number, okay, for this public key. So when you generate your public and private key pair, the algorithm that was used will be identified using this algorithm number. Okay, and of course it shows you as well this public key. Why doesn't it look too long? Because it's in base 64 format. Now after that, anything after the semicolon in DNS is usually comments. Okay, this is a comment, but it gives you information about the key ID. So it's easy for you to map because you can generate so many sets of keys perhaps. So it's easy, okay, by looking at the key ID that this corresponds to this particular key, right? So that's your DNS key. Other information that you can find in DNS key now is what we call as timing metadata. So when you generate this set of keys, okay, you'll have a created, time, publish, and activate. In this example, they're all the same, meaning once I created it, I'll automatically publish and this is already activated. However, you can make it so you create the key now, publish it maybe 2 weeks from now, and activate that a month from now. Okay, so different dates. So you generate it first, so you have some overlaps with the previous keys, and then it is published and activated much later on. Okay, these are metadata that comes with your DNS key. Next one, RRsig. So RRsig is a signature of the RR set, remember? So what does it look like? So for this, okay, I have 2 NS records where the formatting did not come out good in this presentation. So yeah, I have 2 NS records. I'll come up with a signature for this NS record. So I have this. This is my RRsig from this line. Okay, this is a signature of the NS record. How many records I signed? I signed 2. So again, it's not properly formatted, but this red one shows the NS record supposedly. The orange one is the algorithm, which is which should be 5, and then the number of labels signed by the signature is 2. And then we have this dates. I'll remove that for now so you can see clearly. 2012, 1202, and some more minutes and seconds there. So that is when it is generated. The validity of the signature is generally 1 year. You can set it to another value later on, but yeah, it's usually 1 year, and then it expires. Okay, date signed and then date expiry. So this one was signed in November 2012-11, and it will expire in December 2012-12. Okay, so I generated this like years ago. But yeah, it's still the same setup until now, right? So that's an example of your signature. Next, the NSEC record. So NSEC, as I've said, is your next secure record. Okay, it shows you the next owner name. It shows you the RR types that should not be part of this. So it basically proves that a particular domain or resource record should be non-existent in that domain. Okay, and you can use either NSEC or NSEC3 record. So an example is this small record that you find here, myzone.net. Resource record type is NSEC. What follows is blog.myzone.net. And this is the linked list. So basically, I know that before this NSEC record, I have an A record, followed by an NS record, followed by a SOA, MX, RSig, etc. So if someone maliciously inserted an A record, say for example in between my SOA and my MX record, you can see here, it's not supposed to be there, right? I should only have SOA and then MX record. There's no A record in between that. So I can respond accordingly that say you cannot validate this because this should not be existent in the first place in this domain or in this zone. So I hope that's clear. Okay, that is the purpose of NSEC. Okay, so again, NSEC R data is this part. this part where you have your basically your list of resource record types. Okay, it's used for authenticated denial of existence of your data. Okay. Another example of NSEC here. Again, it's not properly formatted. Forgive me because for updating into the application, sometimes it's not properly formatted. But you can see you have a SOA record, you have an NS record, you have a DNS key record, and then followed by NSEC. So this NSEC says that what follows after this record is mailbox. So here's your mailbox.example.net. And then in my R data, I have this, SOA. Okay, so try to follow this and look on top. SOA followed by NSEC. I should have an NSEC record here before the DNSSEC, but yeah. So basically SOA and NS followed by this NSEC. And then after that, you have your DNS key and then some RRsig. Okay, so it lists down all the resource records mostly before and then one more after this record. Now, what's the purpose of NSEC 3? Notice that in the NSEC record, the list is actually showing, right? We said that DNSSEC data, you don't encrypt it. Okay, there's no need to encrypt it because it's for validation. However, by doing this, you're also exposing what are the records in your zone file and the order that they come, right? Because it lists them down. And these are all in clear text format. So someone can use this and do what we call as zone walking. Okay, so you can go through each of the records in your zone file by just looking first into the NSEC record. So as a solution, we are going to use hashing algorithm. How? This part, the part where you have the R data part, where you have the records, the list of the records, will now be hashed. We use a hashing algorithm added with a salt, okay, and then use that to come up with a hashed value that will now go into our data. Note, however, that for proficient attackers, you're not totally avoiding zone walking here. However, the cost to do this is very, very high, such that it's quite impossible for someone to actually, it's very costly to implement this for them. So it doesn't matter. They want, most of them will not be enticed to, do zone walking anymore because of the computational cost that comes with it. That's your NSEC and NSEC 3 records. Questions? Okay. This class is pretty quiet. I hope you are understanding the concepts, right? I'm going through all the records and their functions and pretty much how they look like. Now, I guess your question is, okay, those are the records, but where do I find them? They will be added into your zone file. What is the content of your zone file right now? Your A, quad A, pointer, NS records, right? You have that in your list in your zone file. Now, once you sign your zone, okay, this is what we call as DNSSEC signing. Once you have signed your zone, okay, you will also see these records added up into your zone file. So the actual output will now become a lot bigger because aside from your typical records, you'll now have DS record, okay, RRsig, or DNS key records added there. Okay, this is an example of a DS record. Once you sign your zone, okay, this is when this DS record will be generated. So you'll have another file that contains your DS record. Generally, you'll have two. That's why you see here, irashai.net, you have, this one, in DS record, and then in DS record. I have two DS records by default. Why two? Why not just one? Okay, that is because, let's just go back there. We are going to support two digest types, SHA-1 and SHA-256. We know that SHA-256 is the preferred hashing algorithm over SHA-1. SHA-1 has got some weaknesses. It is kind of like prone to collisions nowadays. So we prefer SHA-256. However, there's still so many DNS servers that do not have support for this. So we have both to support SHA-1 and SHA-256. You can see that here. This one, so this is for SHA-1. You have here this type 2. This is for SHA-256. So normally, once this is generated, where does it go? You forward that to your parent zone. Okay, this is for the chain of trust. You give this part to your parent zone. So for example, I'm training.apnic.net. I want to sign my zone. What do I do next? I do the signing. Okay, there's a process. I can show you the commands later. But I sign my zone. And then I now have a signed zone file. And I have my DS records. This DS records, I will give that to APNIC.net administrators. Another, if say you have your own domains, you got that from a registrar or registry. Say for example, so it's easier, say, what are the popular ones? GoDaddy and things like that, right? You can buy your domains there. So once you generate your DS records, they usually have a form that you can fill up and copy and paste your DS record. And then the system will add it into their own DNS servers. Okay, I'll show you. I might have some screenshots later on. Does that apply to DNS key added only to the parent zone? No. The DNS key is generated when you sign the zone. It is added into your own zone file. Okay, so only the DS record will be added into a separate file, which you will now have to forward to your parent zone. All the others are SIG, okay, DNS key record, NSEC or NSEC3 records. You will see that in your zone file. You don't have to copy paste or you don't have to generate them separately. Once you sign, it will be there. You will see it in your signed zone file. Okay? A few more things about the DS record. Okay? It indicates that delegated zone is, of course, digitally signed, but it goes to the parent. The parent is authoritative only for the DS of the child. Okay, because all the others have already been delegated to the child zone. So it's not for the NS record. DS should not be added to the child zone. It should be on the parent zone. Clear enough? Okay. Again, questions on the chat. If I'm going too fast for you, please let me know. I can explain them further. Okay, now going back to chain of trust. Remember in how DNSSEC works slide. Okay, if you have a PDF copy, you can go back there. Okay, the last two parts, the last two bullet points is about chain of trust. Parent to child. How do we cryptographically link them together? That's what we're doing here. Chain of trust. Chain of trust starts from the root. Okay, that is the peak or the entry point of the chain of trust. And then from the root goes down the top level domain, goes down until it reaches the authoritative basically zones. Okay, so how parent does not sign the child zones, we already know that because you're independent like that, but parent will sign the child's zone. Does that make sense? So again, you generate a DS record. What is the DS record? It contains the hash of your public key. Where is your public key? Your public key is stored in your DNS key record. So a hash of that record will be in your DS record. It's not going to be added on your zone file. You'll have to give that to the parent. Now, how do you establish the chain of trust? It's not just by adding it to the parent zone. The parent zone must then sign it. Okay, for that verification, the parent zone signs it, signs that pointer. How? When it does the DNSSEC signing, it also signs a DS record that's added there. Okay, so in a way, that's kind of like signing the child's public key. Okay, so that's how we do the chain of trust. Any questions? So you do understand the 4 resource record types and their usage and how they look like in your zone file, right? Now, One other very important topic that we have to cover is creation of keys. In the DNS key record I showed you, okay, you have either an option, not option, but you can see there whether this key is either a zone signing key, ZSK, or a key signing key, KSK. Again, ZSK, KSK. But why do we have that? So this should explain that. So far in our explanation, we just said that you will have a key, okay, public and private key pair. You use that key, you publish a public key, you publish a signature. That is the main concept. But whenever you do that, what happens? You will have a new set of DS records. You'll have to go to the parent and give that. Say, for example, first time that I sign my zone, okay? So you're excited. You signed your zones. You know, you understand the concept and everything, so you sign your zone. You have a DS record output. You give that to your parent zone. That's it. However, most of the time you make changes in your record. It's not static data, right? If you have new machines that needs to have mapping, you create another record inside your zone file. So that means you manipulated the zone file. Once you do that, you have to sign it again and then give the DS record to the parent. After another week, okay, one of your servers has been, maybe you're not using it anymore. So you want to remove an A record from your zone file. So you did that, you edit it into zone file. Again, what you have to do is sign it again and then new DS records to your parent. What does that mean? Every time you make changes, okay, you have to go through that administrative tasks of sending the key, coordinating with your parents to make all of these changes. Okay, so how do we solve that problem? Because, for example, think about a big parent zone, maybe one of the top level domains. Think of .com. .com have thousands of subdomains. Imagine all of that, signing their records and then signing it every couple of months and then going back to the .com server and then asking them to change it. That's a big administrative task. So in practice, we're actually going to use two sets of keys, KSK and ZSK. One of the key will be used to sign the zone, so that's the usual one that I have already covered, and the other one will be used to sign the key. So think of it that way, two sets of keys, one key to sign the other set of key, the next set of key to sign the actual zone. So you have two levels. Okay, so the KSK is used to sign the ZSK. The ZSK is used to sign your zones. So generally, when you created these keys, okay, the lifetime will be, of course, up to you. There are defaults, say 1 year for ZSK, 2 years for KSK, or 1 month for ZSK, or 1 year for KSK. It's up to you what you want to do, like how often do you want to change these keys. But generally, KSK lifetime would be longer. You set it to a longer because, sorry, not lifetime, KSK length will be longer because you generally expose that on the internet longer. You don't change that very often. The ZSK, you can change that quite often because it doesn't really affect much of the parent zone, right? So you can change that. It's important because you're exposing your key. It's important to have a timeline when you are going to change, okay, or generate a new set of key, new set of key pair, right? So that's your ZSK. Those are the two keys. ZSK is used to sign your resource record sets within the zone. So it essentially signs the zone. It is signed by the KSK. KSK is basically signing the ZSK, and it's what you use to, basically pointed to by the parent zone. So this key, the hash of this, is your DS record that goes to the parent zone. Okay? Right? I can see some people typing on the chat that then stop. So if it's not clear, again, please feel free to write them down in the chat. Okay, now, fewer more things to remember when it comes to key. Why do we generate keys and why do we generate them often? It's because, again, we're exposing them. And so the longer that you expose these keys on the internet, okay, you're giving time for attackers to do their thing, to do, say, reverse engineering, to find out the key. Okay, so you have to change it. Some of them change it every 30 days, some of them change it every year. It will be, again, up to your own policy. But one thing to be sure, keys actually do not expire. If you don't want to change it, you have that option. But you're exposing yourself by doing so. Okay, that's kind of like a weakness if you don't change or generate new sets of keys. But obviously, keys do not expire. However, okay, the signatures have a validity period. The keys don't, but the signatures have. So you use the key to sign the zone file. So if you look at your RR-SIG, which is the signature, right? The RR-SIG. The content of your RR-SIG, you have there the publish date and the expiration date. Usually it's 1 month, 30 days. Remember, we have an example that shows 2012-11. It's generated in November and it expires in December. So every month. Okay? So there is a validity period. You can change that maybe to longer or shorter depending on your needs. So what does that mean for you? If you keep it to this value, you have to re-sign the zone every month so that the signature, okay, new signatures will be generated, okay, and you're kind of like extending the validity period, okay, because what happens if it's expired? It will no longer validate. If I have a resolver, we call it as a validating resolver that can understand DNSSEC. If it resolves, got the value of your, say, your A record, you have a signature there, but it's expired, it will not validate. Meaning it will not give the answer to the client. Okay? Basically, the outcome of that is we cannot see, say if it's a web server, the client cannot get to that web server because, because obviously, okay, I don't have the mapping. It has not been forwarded to the client. So it's important to know when you have to generate the key, when you have to re-sign your zones. Okay, you must have a process to do that. So I guess most of the time, okay, the initial signing of DNSSEC is quite easy as long as you already understand the concepts, which we have already covered. But after that, there is an ongoing process that you also have to do. Okay, the keys expire, so you have to generate, the signatures expire, so you have to generate or re-sign it again. The keys, you want to also change them quite often. So you have to think of those things once you do DNSSEC. Okay? So that's the DNSSEC signing part. Who does that? If you are an authoritative zone, if you have a domain, if you're in charge of a zone, then you have to do the DNSSEC signing. Now this part is the validation. So if you're in charge of a recursive DNS server, you also enable DNSSEC on that resolver so that you can verify. Okay, so they've made their domains, they made their resource records verifiable, but you're the one who will get that record from the authoritative server. Once you get that, it comes with a signature. So it's up to your validating resolver to check, to validate that this is the correct information given the signature and the public key. Clear enough? So in this slide, what you are seeing is the rate of DNSSEC validation around the world. This information, this diagram, you can see that in our stats, in our labs. So that's stats.labs.apnic.net. You can have a look. and see which economies are doing DNSSEC validation. So the greener it is, meaning the more DNSSEC validation or the higher DNSSEC validation rate is being done in that particular economy. Okay, so have a look at that and see how your economy is faring with the rest of the world. Okay, so again, just to enumerate the steps, if you are doing validating resolver, what you have to do, so you're not in charge of any what do you call it, domain names, right? You're doing validation. You have to enable DNSSEC on your server, and then you have to enable DNSSEC validation. Once you have done that, when you do a query, it will have what we call as, like, if you say, for example, you do a dig query. Aside from the typical flags, it will now have an 8B bit, meaning it's authenticated data. Okay? If you see that, means that the authoritative server for that zone, for that, say, domain, okay, has signed their zone, and then you have validated that it is correct, that the data that came to your server is actually correct. Okay? If you want to just try DNSSEC validation, say for example as a typical user and then your zone administrators have not enabled DNSSEC validation yet, you can try using online tools. So say for example for a web browser, you can look at this or this links here, DNSVis, DNSSEC debugger. I think one of them have been down for maintenance for quite a while. But if you want to configure your machine to use a recursive server that is doing validation, you can set it to these IP addresses. These are public open resolvers. Okay, but the best way is, of course, once you have the chance, okay, enable DNSSEC validation on your machines. On your validating resolvers. Questions? No questions? Now we're not done yet. I think I still have just a few more slides that covers the steps on setting up a secure zone. So far we've covered all the concepts. We know that when you sign, this is what happens. You know that you will have a zone file with all these new resource records. You know that you have to generate new sets of key. But how can you do that? If you are using bind, okay, bind again is the most common DNS software that is used by about 70 to 80% of DNS servers around the world. These are the commands that you can do or changes that you can add in your configuration file. First, you have to enable DNSSEC. You can add these two. Now, I think by default, DNSSEC enable is already set to yes, and DNSSEC validation also set to yes. But it's always good to add this on your configuration so you know that yes, actually you are using DNSSEC validation. Okay, so it's a good indication and also kind of like documentation for whoever is going to look at your DNS server. Now, the next step after that is you generate your key. You are going to use this command twice. DNSSEC keygen. You generate a key using an algorithm. In this case, I'm using RSA shell 1, but it has support for other algorithms as well. This is the number of bits in my key. It's set to 1024. This is good for a ZSK, but may not be good in a KSK. You want it longer. So either use 2048 bits or maybe if you want 4096 bits. Okay, and this minus n zone, and then this is your domain. Okay, that's your domain pretty much, or your zone. Next, after that, you publish your public key, okay, by adding it or including it into your zone file. Okay, a simple include statement pointing to the file of your public key should be enough. You should have two, one for KSK, one for ZSK. So the public key of your KSK and ZSK will be added into your zone file by adding an include statement. Next, you do the signing. I think I have Okay, I still have that here, so I guess I can go to that one. This is the generation of key, DNSSEC key gen. You have to do it twice. So the output will be 4 different files, right? One set for ZSK, one set for KSK. So in this example, see here, I'm using 1024 bits for ZSK, 2048 bits, which is longer, for your KSK. For the actual signing, okay, this is the publishing part. For the actual signing, the command is DNSSEC sign zone. So I can do something like this, DNSSEC sign zone -o, myzone.net, which is basically your zone, and then db.myzone.net is your zone file, your database file, and then this is the key that you will use to sign it. This is your KSK. In this case, what am I using? This is just a ZSK. You can use both KSK and ZSK. By the way, you can use only one key, but it's not general practice to do that. You generally would have 2 sets of keys, KSK and ZSK. But if you want, okay, you have that option to just use a single key pair. Once you have done the signing by using this command, DNSSEC sign zone, the output will be, okay, if you don't specify a particular file name, the output will be the same file name as your zone file. Say, for example, here we use db.myzone.net. The output sign file will still be db.myzone.net, but with an added .signed extension. So this is a newly generated zone file. When you open the contents, it still has your original A records, quad A records, and all of that, but it will now have an additional RRsig, okay, DNS key record, NSEC or NSEC3 records. Okay, fair enough? So that's pretty much how it will look like. That's why the output file will be much, much bigger than your original zone file. So be careful when doing this. With the signing, if your original zone file is not that big, then the process is actually pretty simple and pretty straightforward. Okay, it will be quick. But if you have a very, very big zone file, it might take a bit longer, and the output signed zone file will be much bigger in terms of file size. Okay? Note that only authoritative records are signed. So you have NS records, they're all signed. DS records are signed, but glue records are pointers to the child zones. Glue records will not be signed. At the same time, NS records for all the delegations, basically again pointing to the child zone, will again not be signed. Okay, notice the difference in the file size of your original zone file and your signed zone file. Nowadays, we already have like smart signing, so you don't have to specify the ZSK and KSK every time in your DNSSEC sign zone command. You usually can just add it into a repository or a folder, and then you specify that directory in your named.conf, and it will look for the keys from the particular directory. Okay, and then you can pretty much do the signing. So it's not a very long command anymore. Okay, once you've done all of that, so you now have your signed zone file. What's your next step? You go to your named.conf, look for your zone statement. This is a zone statement, okay, for myzone.net. It's originally pointing to this zone file, but I want it now to point to my signed zone file. So that's what I'm doing here. Just changing named.conf and pointing to that new file. Once I've done that, okay, I can now test. You can do a simple dig command, add a plus DNSSEC, and then the output will be something like this. I'm not sure if you can see this very clearly, but in here, I did a query for irashai.net, and my answer, I'll have 2 answers. One is the A record, which is the default output when I do a query without specifying the resource record type. And then at the same time, I have the RR sig. Notice this one. This long one is my RR sig, okay, for this A record. Now, if I do a long query, so it will have the authority section. So everything, particularly, even for the NS record here, it will output the corresponding signature for that record. So essentially, okay, whatever record comes out of your query, okay, if there is a corresponding signature for that, it will also be printed. Okay, so you have all of that. That's your output. Okay, the multi-line, by the way, is just for framing it. Okay, so it doesn't look very cluttered. So it's easier to see which one is your the content or the signature of your resource record. Publishing your DS record. When do you do this? Give this to your parents. Remember, DS records must be forwarded to their parents by either contacting them, sending them an email that, hey, this is my DS record, or maybe through a form. They provide you with an online form that you can fill up. Now, there are proposals in IETF to change this so that's automatic. It will be forwarded to the parent using the DNS infrastructure and not outside of this. But it's still a long way to go for that. So right now, the step would be once you have signed your zone. Okay, you sign your zone, your next step would be to give the DS record to your parent zone using those means that I've told you about. This is an example. This is the form for GoDaddy. Create a DS record, you provide the information, each one, key tags, algorithms, digest type, and the actual digest output, and then click on submit. If it is a reverse zone, right, you also need to sign your reverse zone. Say you have an IP address coming from APNIC. Say, for example, here, I have 61.45.248/24 from that I received from APNIC, and then I sign my reverse zone. Now I have a DS record. How do I add a DS record to the parent? Basically, that's using my APNIC. So you edit the whois object, and then add a DS RData field, and then here you insert the content of your DS record. Okay, that's how it works. Yeah, so that's pretty much it. That's those are the steps that are involved in signing your zone. Okay, DNSSEC signing is quite a tedious process if you're just starting with it. Once you have the grasp of the concept, which we have already done, okay, you now have to make a plan on how you're going to implement it. Those are the easy steps, but you also have to think of, once you've done this, when or how often do I generate, or how often do I sign, etc. Okay, those should be all part of your plans before you actually sign your zones. Okay, do we have any questions about this topic? Was it hard? I hope you guys had understood most of the concepts that we have discussed. Now, I don't see any activity in the chat, so I'm hoping that the concept is clear. So right now, what we can do is, if you can, click on the link and then fill in the form there. I'd be very happy and grateful if you do that. At the same time, you also have this link for the slides. So you can download that and you can review that on your own time. If you have any questions after that, please feel free to send us an email to training@apnic.net, and we'll be happy to answer them and clarify those things for you. Okay? So if there are no more questions, I think that's where we will end this session. Thank you very much for your time and for your attention. Yeah, we have another session later on that is still related to DNS. I think that's reverse DNS. If you want to attend, that is going to start at 3 o'clock, about 42 minutes from now. No, 48 minutes from now. So that's pretty much it. That's it from me.